Hi, welcome to Computing Foundations. This is a YouTube channel for beginners who want to learn about computers, programming, and the math, science, and art behind this world-changing field. I'm Josh Kilpatrick, a software engineer who's retired. If you will, take a second to like, subscribe, and comment to help me improve this channel. Today we're going to be going over the solution to programming challenge number 15. This challenge accompanied our lesson on dynamic memory, and I think it was a really fun program to write. So I hope you enjoyed it, and let's dive right in to how to solve this properly. First of all, I thought I would just show you the working program so that we're super clear on what it is or what it was that we were trying to create. So here I'm going to run my program, and you can see here I chose to just start the program. I don't print anything out. And now I'm ready to receive user input, and I can type as much as I want. I can type as much as I want. I can put enter. I can say this is a program to capture all the user's input. They can type as much as they want. And then finally, when the user's finished, they can simply type the single letter Q on a line and then hit enter, and the program will exit. But before it exits, it prints out statistics about what was captured. So I print out that the size of the storage area that I've dynamically allocated is currently at 160 bytes. The length of the string that the user has entered that I've captured into memory is 120 characters long. So I have more storage buffer, more storage area available right now than the user has used. And the word count for what is in what the user entered is 25. There's 25 words there. So this is our goal. This is what we want to write. All right, so if you aren't looking at it yet, open up number 15-challenge from the code repository that accompanies all of these videos, and I'll start to walk you through how do we solve this problem. So first of all, I set up three different global constants to be used. I say the starting storage size will be 10 characters. The growth rate for my storage will be 2, and the size of my read buffer will be 10. So let's take a second and visually take a look at what is it that I'm setting up, that I'm going to set up here at the beginning of the program. So keep in mind that the way that the C input system works is that the user types into a keyboard. Whatever the user types goes into a imaginary buffer in memory called the standard in buffer. Now, when we want to read from the standard input buffer, we use the fgetS, get a string from standard input, and we give it a local buffer that we've defined, an array that we've defined, and my buffer is of size 10, so I give it the size of my buffer, and then I tell it I want you to read from standard input. And the fgetS function will fill up my local array that I've defined with whatever happens to be in the standard input. Okay, so that's what we're trying to get set up. And then we've set up a storage area that I'm going to call store, which is where I'm going to copy the buffer into that area. So let's jump back to the code and see how do we set all of this stuff up. So I'm going to move past the two functions that I've defined here all the way until I get to line, for me it's line 84, my main function. So let's take a look at what I'm doing. First, let me get you to the code here. First, I set up some variables that'll be used to represent the storage area where the user's data will be stored. So the first thing I do is I set a local variable called storage size, and I set it equal to the starting storage size, which will be 10 bytes. Then I allocate a block of memory that is whatever my storage size is times the size of a character. So this will end up being 10 bytes, 10 characters, and I'm pointing to it using my store. As a best practice, I always check to make sure the storage pointer isn't pointing to null. If it's pointing to null, then we had some sort of memory allocation error. We need to just exit the program. The program's going to fail. Then I take an initialization step. I set the 0 index position of my storage array to the null character. By this means I'm simply indicating that the string that is stored in the storage area right now is of 0 length. There is no string. I just have an empty storage area. And then I create a variable called storage tail, which I'll talk about in a minute, or actually let's talk about that now. So what I'm creating here is a pointer or a variable that will hold the index of my storage area that is currently the tail of my string. It is the first position where I would add in new data. Okay, so the tail of my storage area is going to represent the very end of the current string that I have stored, and it's going to basically be, this is where you should put the new stuff when you read new things in. Okay, so I set the storage tail equal to 0 initially because I want to put things at the very beginning of the array. Next, I allocate a buffer for reading in from the standard input. I do this because it's just easier to read into a fixed area and copy it into my storage area as I go. That makes the program a little easier to write. So I set up a variable, a character pointer called buffer, and I allocate the read buffer size, which I set to be 10, the same size as my storage area initially. And I verified that the buffer exists, and I set the first bit, the first index, the 0 index, to the null character, indicating my buffer is empty. All right, now I start an infinite loop. This technique I'm using here, while one, is just a simple way of saying, run this loop forever. Never stop the loop, just run it forever. I have no condition. By saying while one, I'm saying forever, because one is true, so just forever run this loop. And I enter into the loop, and we're going to begin the process of how we want this program to operate. It's going to repeat this process over and over until the user enters Q. So let's visually take a look at what is this process. All right, so I have a storage size, which has been set to 10. I have a buffer. I have a storage pointer that's pointing to an array that I've allocated in memory, and I have a tail. So at any given moment, the storage size, which is 10, minus the tail, whatever tail is pointing to, is going to be the amount of space that I have left in my storage area for storing things. So let's take a look here. I have 1, 2, 3, 4, 5 characters in my storage. This is fictitious. We haven't really done this yet, but I'm explaining how it will work. So let's say we have 5 characters in our storage. That means the storage tail will be set to 5. Why is it set to 5? Well, the first index of the array is 0, 1, 2, 3, 4, and it is the 5th element. The 5th index, which is the 6th element of the array, is the first available space where I can store something new. So if I take storage size 10 minus 6, I end up with 4. There are 4 remaining spaces in my storage buffer, in my storage area. This is also the same thing as, if I take the string length of my buffer, depending on how much I've read in from the standard in, and I compare it with the amount of size that I have left, that will tell me whether or not I can fit my buffer into the storage area or not. So really quickly, this storage area that I've drawn is more than 10 spaces. I just drew it carelessly. So let's just review. This is position 0, 1, 2, 3, 4, 5 is my storage tail, 6, 7, 8, 9. So this area here doesn't really exist. My storage area only has a space of 10. So when I take storage tail 5 minus 10, I end up with 6. Storage tail minus 10 equals 4. So I have 1, 2, 3, 4 spaces where I can store more information, more characters from the string. Why only 4? Why not 5? Well, I need that 5th one for my null character, for my termination character, so it's not really available. So storage size minus storage tail equals how much space I have available. So what I'm going to do first is I'm going to check to make sure I have enough space available. If I don't have enough space available, I need to grow my storage area. So the way that I'm going to do that in my code is I'm going to set up a new pointer to a new storage area. I'm going to malloc the current storage size times 2. So I'm going to double my current storage area from 10 to 20. Then I'm going to string copy from my old storage area into my new storage area. So now my new storage area has the 5 characters. Storage tail remains unchanged. It can still point to the 5th position. I don't have to change it. Then I'm going to free the storage area, and I'm going to set the storage area equal to the new storage area. So when I'm finished, my storage area now points to a new area that is larger than it was before. So let's take a look at the code and see how do I actually do that in the code. All right, so first of all, I do fgetS. I read in from standard input into my buffer, and I indicate to the fgetS function, you can't read any more than 10 characters into the buffer. The next thing I do here is I check the buffer to see, is the buffer null terminated? Now, on my operating system, fgetS is implemented so that it always produces a null character at the end of the string. It will never read in so many characters that it can't null terminate my string of size 10. But some platforms are different, and fgetS can fill up the entire buffer without a new line at the end. So I like to check for the new line. So I'm checking I like to check for the null character. So I check for the null character. If the null character doesn't exist in my buffer, well, then I'm just going to assume that the size of my input that I've read in is the size of the whole buffer. So that would be string length equals 10. Otherwise, if I do find the null character, then I'll set the string length to the output of the string_ling function, which just counts the number of characters in my buffer up until it reaches the null character. Okay. Now, I've read in the buffer and I've checked to see how large the buffer is. Now I want to find out, is the buffer simply a \q? So I'm going to compare the buffer to q plus a \n, which is the new line, to say, have I received a buffer that is simply the q character and a new line? The user hit enter after the q. If I have encountered a q, I exit out of the out of the loop. That's what this break statement does. It says, hey, I don't care that this loop is set up to run forever. If you get to this point of the code, break out of the loop and fall to the first line of code at the end of the loop. So that's how I get out of the loop. All right, the next thing I want to do is check the size. If the storage size minus the storage tail is less than or equal to the length of the string, so if the length of the string is 5 and I only have 5 positions left in my storage area, I can't store a string of 5. Why? I need a 6th element of the array where I can store the \0, the null termination character. So I need to make sure that the available size in my storage area is the length of the string plus 1 at least. That's how much I need to store a buffer. All right, so if it's not big enough, I'm going to create a new storage area that's equal to the current storage size times the growth rate, which we had set to the variable 2. See, growth rate equals 2, so I'm going to double the storage size. Then I'm going to copy the storage area into the new storage area up to the current storage size. So current storage size is the total size of the current storage area. I'm going to copy into the new storage area, which is storage size times 2. So there's plenty of space to put the entire storage area into my new storage area. Then I'm going to free up the old storage area. I'm going to let the computer delete that memory. And then I'm going to set the storage area equal to the new storage area. So now, as I'm exiting this block of code, the storage area has doubled in size and it still contains all of the data the original storage area contained. Finally, I increment the storage size to be twice of itself. So storage size equals storage size times the growth rate. So now I have 2 times as much storage. That's how I grow my storage. Now finally, I only did that block of code to grow if I didn't have enough room. Now I know I have enough room and I'm ready to do my copy operation. So I'm going to take a pointer to the storage area at the index of the storage tail. Remember, the storage tail is where I'm ready to start inputting new data. So I'm going to execute a string copy starting here into this area of the buffer for whatever length the buffer has, however many characters are in the buffer up until the null termination string. All right, looks good. Let's jump back to my code. After I've done that copy, I'm going to advance the storage tail to the string length that I just stored, and I'm going to set the new storage tail to have the null terminating character. Let me see, did I show an example of this? I did. So what's going to happen is my storage area where the storage tail equals 5, let's say my buffer has a string length of 3. I'm going to copy these 3 characters into the storage buffer using the string copy command. And now my storage buffer is going to have 8 total characters, which means the 8th index, which is really the 9th character, is where the new storage tail needs to get moved. So if I say storage tail plus the string length, 5 plus 3 equals 8, so that's how I advance the storage tail to the new location where it needs to be. All right, that's it. Once we've done that, we go back to the top of our while loop and we keep running it forever, unless, of course, we detected the queue on a single line. If we did, then we'll fall out of the while loop to line 151, where I print out the current size of my storage, the current length of the string that's in storage, and a count of the words. So now, let's discuss a little bit, how do we implement counting the words in a string? this is a fun little algorithm in and of itself, and I want to spend a little bit of time walking through that algorithm with you before we look at the code. So let's imagine that a user entered, "Hi, my name is," return, Josh, return, and then a Q on a single line and a return. So this is what the user entered, and now we want to print out on the screen the statistics. So let's consider carefully what will be in the storage area after the user has made this input. So we're going to have hi and then a space, my space, name space is the new line character, which is represented as \n, Josh, the new line character because the user hit an enter, and then finally a \0 end of string terminator. So this is what the storage area would look like. A couple things I want to call to your attention. Store is a pointer. Store +2 is the location of the first space. Store +5 is the location of the second space. Store +10 is the location of the third space. Okay, so if we go through the array finding each of the spaces, we essentially are counting the number of words in the string. So hi, space, that's word 1. My, space, word 2. Name, space, word 3. Is, new line, word 4. Josh, new line, word 5. So we need to find the spaces and the new lines. In programming, these are commonly called white spaces. These are spaces that separate words. So we're just going to assume the user isn't going to enter anything weird like a tab. We're going to assume the user is just entering spaces and new lines or enters. So how do we find each of these spaces and count the words? Keeping in mind, there could be a little glitch in the system. Imagine that the array looked like this. Some letters, a space, some letters, and then 2 spaces side by side, and then some letters, and then some letters. If I counted the spaces here, I would get 1, 2, 3, 4, and then another one here, 5. But there's really only 1, 2, 3, 4 words. So I don't want to count the white spaces if they're side by side. If there's not any word between them, I don't want to count them. So how do we accomplish that? Well, I want to teach you about a technique called a trailing pointer technique. And this is something that comes up in a lot of different algorithms in computers, where if I use 2 pointers, I can accomplish something that I can't accomplish with just 1. So here's how it works. I set 2 pointers to the beginning of my array, next and previous. Then step 1, I execute a search. I search for the first occurrence of white space. I use the strchr string char to find the first white space, and the result will be my next pointer will be moved to point to that white space. So the second step is I compare the 2 pointers now. I say, hey, previous and next, are they far enough apart that there is a word between them? So what I would say is, if next minus previous is greater than 1, then something must be between next and previous. They're not side by side. Another way to say it is, if previous plus 1 does not equal next. So if by moving previous forward 1 step, I'm not at the same place that next is at, well, that means something is between the previous and the next, and we should count that thing. Finally, I reset into the new white space, next and previous, and I start the process over again. So I'm going to walk through the array, slowly advancing the next pointer, looking to see if the next and previous are far enough apart, then moving the previous to match, then moving the next pointer, checking to see if they're far enough apart, then moving the previous pointer to match. So by using this technique, we'll end up counting the spaces, but then what happens when I get to this point where I've got 2 spaces? So I've reset, I'm pointing at a space, and I'm going to advance the next pointer to find the next space. But then when I do the compare operation, I say, wait a minute, previous plus 1 equals next. So these 2 pointers are just side by side. I don't want to count that as a word, so I don't count it. I move previous to equal next, and I continue. So this is how we avoid counting double white space that's been smashed together. We have these 2 pointers that are following down through the string. So let's take a look at the code and see how did we accomplish that. Up here at the top of the file, I have defined a simple function called find the next white space. It takes a pointer to a string, and it returns a pointer. So what happens? First, I check to make sure the string you're giving to the function isn't null. Okay, if it is, I just return null. I say, hey, I didn't find any white space. Next, I call the string char function twice. The first time I call it, I say, look for a space. The second time I call it, I say, look for a new line. So now I have a pointer to the next space character and the next new line character that was found in the string. Okay, now I'm going to do a little bit of kind of a little confusing math. I'm going to say, hey, if I found a next space and I found a next new line, I need to know which one came first. Because I searched for 2 different things, they both can exist in the string. We need to know which one comes first. So I do a little comparison. Hey, if the next space is less than the next new line, well then I'm going to return the next space. So that's saying if the space comes before the new line, then return the pointer to the space. Else, return the pointer to the new line. But possibly I didn't find both a space and a new line. That's also possible. So in my else statement, I'm going to say, well, okay, if I found a space, return the space, else return the new line. If I found neither, then I'm just going to end up returning null. So this simple function uses 2 calls to string char to help me determine what is the next white space. Is it a new line, or is it a space, or is it neither? So that's how I simplify finding the next white space. Now I'm ready for my count function. So again, I pass in a string, and I'm going to pass out how many words did I find in the string. So first I check to make sure the string is not null. If it is null, I just return 0. I say there aren't any words in this string, return 0. Next, I set up a variable called word count. I set up 2 character pointers, my current white space and my previous white space. And I'm going to set them both to the beginning of the string. Now I start a loop. I say, go find the next white space and set my cur space pointer to that white space. As long as I found something, as long as it's not null, I'm now going to check to see, hey, if I take the current space, white space, and I subtract 1 from it, does it equal the previous white space? As long as it doesn't, there's more than 1 space between them, I increment my word count. Okay, if they're equal, I do nothing. Then I set the previous white space equal to the current white space. I'm bringing the 2 pointers together again. And I increment the current white space by 1. I move forward by 1 space past the current white space. Then I'll execute the while loop again. Excuse me. I jumped us away from where I wanted to be. I execute the while statement again, but now current space has been moved forward. So I'm searching from the space just beyond the last white space, and I'm trying to see if there's another white space in the string. And in this manner, I can count all of the words and finally return the word count. Now, you might be thinking, Well, what happens if there's something in between the white spaces, but it's not a word, like a punctuation mark? Well, it's true. I will count that as a word. I just decided to use a simple implementation of the word count because otherwise I need to do some comparisons to look for, well, I'm only going to count this if it's an alphabetical character. I'm not going to count it if it's a dash or a comma. I just decided I'll count dashes and commas if they're by themselves in the string as a word. All word count algorithms have to define, well, what am I going to be counting? And I just decided I'll count anything that is separated by a space or a new line. As long as it's not another space or new line, I'll count that separating material as a word. Okay, that's it. That is the end of my overview of the solution to challenge 15. I hope you were able to solve it. And again, if not, don't stress. It's normal that you struggle with these programming concepts as you're first learning them. But the next time you see a problem like this, it'll be that much easier. So keep going. We'll see you in our next video on the next topic in learning the basics of programming in the C language, and I hope you take care.